Stephen Hawking might have been the most famous contemporary physicist in the eyes of the public, but for me it's been Steven Weinberg. Weinberg was one of the recipients of the 1979 Nobel Prize in Physics for his role in the development of the Standard Model. But if people knew one thing about him, it'd be a quote from one of his books. The more the universe seems comprehensible, the more it also seems pointless. I was very fortunate to meet Weinberg in 2015 when I was working on my first book. I didn't ask him about the pointlessness of the universe in general or the pointlessness of my talking to him in particular, but I've always wondered what he might have meant. Weinberg sadly passed away in 2021. In this video, I want to speculate about what he might have meant. Is the universe pointless? That's what we'll talk about today. Weinberg's remark about the pointlessness of the universe always puzzled me, because what did he think we'd find as science progressed? Angels dancing on the tip of an electron-scanning microscope? An army of dark dwarfs that rotate galaxies? A message in the cosmic microwave background saying, "The point of all this is to praise the Lord, hallelujah"? Probably not. When we ask for the point of something, we usually ask for a purpose, the intention behind an action or an object. What's the point of a doorknob? Its purpose is to open the door. Someone put it there with the intention that you can open the door with it. What's the point of me making this video? It's to get these thoughts out of my head and to you, a purpose, an intention. But if something only has a point if it was intended, and the only way that intentions come about are conscious beings, then of course learning more about the universe would not reveal its point. We first need the universe to create someone who has intentions. Now you might argue that the point isn't to be found by scientific inquiry, and that maybe outside of science someone or something has intentions which are the point of all that. That might be, but Weinberg was clearly referring to the changes that scientific inquiry brought. Science taught us a lot, but it hasn't revealed a point, at least not in the sense of a purpose or intention. But this is not the only way we use the phrase having a point. We also use it to refer to function more generally, intended or not. For example, we could say the point of white blood cells is to identify and eliminate pathogens. The point of cell walls is to protect an organism. The point of earthquakes is to release stress. In none of those cases would we talk about intent, because no conscious agents are involved. Or we can look at some negative examples, cases where we say something doesn't have a point. Let's use as an example the unquestionably biggest mystery of modern science. Why do men have nipples? What's the point? We ask that question exactly because male nipples don't seem to fulfill any function. We can explain how they come about. Nipples are formed in the early stages of embryonic development, before sexual differentiation, so both male and female mammals have them. But in males, they don't fulfill a function. They're pointless, like the universe. Bet you didn't expect we'd be talking about nipples today, did you? Okay, so we could interpret point as a function. But doing that brings up an interesting point, which is that in physics we normally don't explain things in terms of their function, not because we couldn't, but because that isn't useful. If we explain human behavior in processes or organisms, we often speak of functions because that makes things easier. It's useful. The point of brushing your teeth is to stay healthy. This type of explanation works in areas like sociology, psychology, and biology. But in physics, it usually doesn't work. We don't say the point of stars is to fuse nuclei. That's what stars do, all right, but it doesn't explain anything. We say instead that stars build up sufficient gravitational pressure to ignite nuclear fusion, and that explains why they shine, not the other way round. If we explain something by its outcome, by the function that it ends up fulfilling, that's called a teleological explanation. And while we normally don't use those in physics, it doesn't mean that we can't. So if we interpret the point of the universe as an explanation in terms of an outcome, what might we be looking for? Once upon a time, one might have considered that a teleological explanation, the point of the universe, could be to create life in general, or us in particular. But it seems that the laws of nature don't care about us or anything like us. It's rather that they give rise to us by way of an accident. This is, I believe, what Weinberg meant with his quote. I think it's what he meant because he said that in an interview in 1997. In the past, it was widely hoped that by studying nature, we will find the signs of a grand plan in which human beings play a particularly distinguished starring role, and that has not happened. I think that more and more the picture of the nature, the outside world, has been one of an impersonal world governed by mathematical laws that are not particularly concerned with human beings, in which human beings appear as a chance phenomenon, not the goal toward which the universe is directed. We also know today that there are other laws, or at least other combinations of constants of nature, that can also give rise to chemistry complex enough to create life. So our universe isn't even special in this regard. But to me, this interpretation of point seems to say that the only acceptable point of the universe would have been to create life. I think that's a bit self-centered. Maybe the universe has a point, but it isn't us. If not, what else could it be? A first try could be the point of the universe is to increase entropy, because that's what it does. But it's a poor explanation because everything increases entropy, so it's not particularly descriptive of the universe in particular. It'd be like describing pizza by saying it's edible. That's right, but lots of things are edible, so it doesn't really tell you much, does it? We do have a teleological explanation for the universe that is highly specific. I've talked about it previously. It's the principle of least action. All systems we know change so that a mathematical quantity called the action will be minimal if evaluated for its entire history. It's a statement about the outcome. So maybe we could tell Professor Weinberg that the point of the universe is to minimize the action. Then again, that doesn't quite work either. For one, as I explained in my earlier video, this teleological aspect can be removed from the mathematics. The other issue is that the principle of least action doesn't include quantum mechanics. Another possible teleological explanation is that the point of the universe is to increase complexity. That's more specific than entropy, but easier to make sense of as life, because we do have some ways of quantifying certain types of complexity. And while I quite like this idea, I'm afraid so far no one's managed to formulate a scientific theory that could generate predictions from it, so we can't be sure it's even correct. A scientifically more successful idea has been that by Lee Smolin, who proposed that the point of the universe may be to produce as many black holes as possible. He called it cosmological natural selection, CNS for short. According to CNS, each black hole creates a new universe with slightly different constants of nature. For example, the new universe might have a different cosmological constant, or a slightly different strength of gravity, or a slightly different mass of the proton. But the number of black holes that a universe produces depends on those constants. And so, eventually, the universes that come to dominate are those which produce the most black holes. He did a lot of estimates and arrived at the conclusion that the constants of nature in our universe are pretty much ideal to produce black holes. You might think that just turning up the strength of gravity would make more black holes, but it isn't that easy. If you did that, you'd create black holes very early in the universe, but they'd be huge and not very many. So you don't want gravity to be too strong. You also don't want it to be too weak, because then matter wouldn't collapse. Similar things happen with the other constants. Make them too large and the number of black holes goes down. Make them too small and the number of black holes also goes down. The value of constants in our universe seems to be ideal to make the most black holes. Then again, if you're willing to say that the point of the universe is to create black holes, you'd also have to be willing to say that the point of life is to make babies, and we probably wouldn't all agree on that, would we? The teleological explanation that I know of that maybe comes closest to Weinberg's point is David Deutsch's constructor theory. One aspect of this theory is that the universe gives rise to universal computers, so that's programmable machines that can calculate anything. It's an interesting idea because it tells you something about which laws of nature are possible, because the laws need to be so that those universal computers can come about. If you're with David Deutsch, then the point of your life is to be kind to computer scientists, because their work is the purpose of everything. To add one final possibility for how we might think about the point of the universe, we could try to settle for less. Rather than asking for a particular outcome, we could ask at least for an explanation for why the universe is this way and not some other. This, I think, has been the driving force behind physicists' quest for a theory of everything. The way we understand the term theory of everything today, it's a theory that unifies the four known fundamental forces: the electromagnetic force, the strong and weak nuclear force, and gravity. But when physicists began talking about this in the 1970s, in the days when Weinberg wrote the book from which the pointless quote stems, they meant more by it. They meant a theory that was unique, that was inevitable, that basically explained itself, one that wouldn't leave any open questions. Weinberg later wrote a book about this too. It's called Dreams of a Final Theory. It was mostly about string theory. But shortly after he wrote the book, string theorists discovered that string theory wouldn't be a unique theory of everything, but rather have a huge landscape of possible theories, each with a different set of values of the constants of nature. This is one of the multiverses in physics, which I talked about in some earlier videos. But the idea that a theory of everything would be in some sense inevitable was always to remain a dream, because a scientific theory can't explain itself. You see, it's like this. In physics, a theory is a set of mathematical assumptions, equations and such, together with a recipe for how to link the maths to observations. The only requirement that the mathematical assumptions themselves have to fulfill is that they should not be inconsistent. To give you a simple example, x larger than 2 and x smaller than 0 are two inconsistent assumptions. However, the requirement that the assumptions of a theory must be consistent in and of itself doesn't tell us anything about nature. There are lots of sets of assumptions that are consistent. If we want a scientific theory, we also have to require that it describes what we observe. It's science, not maths. This means that the requirement that the assumptions describe what we observe is necessary to select the theory. And so one of the reasons for why scientific theory is correct will always be because it describes what we observe. A scientific theory can't explain itself. It explains what we observe. A lot of physicists misunderstand this, and this is the origin of the multiverse confusion. All instances of multiverses are cases when a theory is just lacking assumptions, so it isn't about our universe in particular. You can do this with every theory. For example, you can take Newton's law of gravity and say, I don't specify the value of the gravitational constant, and now I have infinitely many universes, one for each value of the gravitational constant. In Newton's days, physicists would have said that's insane. Yet, that's exactly why physicists say today there's a multiverse in string theory. They have constants whose values they refuse to fix, and then they claim this means all other possible values also exist. So I'm afraid that we'll never have a theory that explains itself, and we'll never be able to say the point of the universe was to live up to that theory. In summary, if you're looking for the point of the universe by scientific means, you're unlikely to find it in the form of an intention or purpose, and a theory of nature can't explain itself. However, the universe might be working towards something that we yet have to figure out. That might be, for example, an increase of complexity or computational power. A scientific theory built on such a teleological explanation would have to work completely differently from the ones we use today. So I find it an interesting idea. Thanks for listening. We'll be back next week.